Tell us, what is a hardware security module, or HSM, and where do they apply?
HSMs, you can think of them like a master vault in a bank for an entire organization's digital security. It's not the vault where you store your money, it's the vault where you store all the keys to everything. It's a dedicated, tamper-proof piece of hardware.
The most important evolution was that HSM as a service concept, cheap and dirty HSMs that use a secure enclave and Intel chips. Walk us through that and introduce us to Futurex's CryptoHub cloud.
It's meant to be not just our cloud HSM or our HSM used in cloud environments, but also your centralized cryptographic service provider. So HSMs are great devices, but as a standalone device, they're not going to do much without interfacing with other applications that are used in security infrastructure. And that's where CryptoHub Cloud has really become a spotlight in an organization's environment.
Welcome back to the Security Strategist podcast, your blueprint for evolving cyber. My name is Richard Stiennon, and I will be your host for this episode. I'm the Chief Research Analyst at IT Harvest, an author, and a trusted advisor to vendors, VCs, and private equity firms. Today, I'm speaking with David Close, Chief Solutions Architect at Futurex, who applies his cryptographic expertise to develop enterprise architectures for PKI, key management, cryptographic processing, and payment environments. His blend of business and technical acumen allows him to build strong customer relationships, and he's an expert in relevant industry standards and practices. Welcome, David. I'm so happy to talk to you. Please introduce yourself. How'd you get to be where you are?
Yeah, thanks, Richard. It's a pleasure to be here. So I've been with Futurex for over 17 years now, and I serve as the Chief Solutions Architect. My journey started in embedded firmware. I've always been drawn to low-level systems where firmware interacts tightly with hardware. And early on in my career, I found myself working on the guts of what we call a hardware security module, an HSM. And that's really where my passion for applied cryptography took off. And I didn't just come into the industry as a crypto expert, but I was curious. And over time, I became fascinated, not just with how encryption works, but with why it matters, how it builds trust between systems, and how it protects the backbone of digital infrastructure, and how it adapts to evolving threats. So today I work on everything from architecture to standards participation, all around various cryptographic standards. And I represent Futurex on several industry bodies, and that includes the PCI Security Council's Board of Advisors, where we're tackling real challenges around compliance and crypto agility. But my focus lately has been heavily around post-quantum cryptography and crypto agility, which is a big shift it's just starting to hit the mainstream now.
Yeah, it really is. And what I love about encryption in general and its application in the security industry is that it has become almost like oxygen, right? It's like you got to have it, but you don't think about it every day, other than the people like yourself that are making it work. But everybody else is just like, everything's encrypted, so we don't have to worry anymore. So let's move on. Why don't we start with the basics, especially talking about hardware security modules. Tell us, what is a hardware security module, or HSM, and where do they apply?
Yeah, so HSMs have existed since the early 80s. They were really birthed in the payment space, but branched out to every other use case and vertical in the industry, and all industries. But HSMs, you can think of them like a master vault in a bank for an entire organization's digital security. It's not the vault where you store your money, it's the vault where you store all the keys to everything. The vault keys, the safety deposit keys, even the digital keys to the security system itself. So if someone gets into the master vault, they don't just have access to one thing, they have access to everything. And that's what an HSM is. It's a dedicated, tamper-proof piece of hardware that protects the cryptographic keys that controls access to your data and your applications, your identities, really your entire organization and your digital infrastructure. So, and just like a master vault, it doesn't just store those keys, it enforces strict rules around how they're used. You can't just reach in and grab one. Every use is audited, controlled, and limited to exactly what they're allowed to do. So whether you're processing payments or signing firmware or code or issuing identities and certificates or encrypting data, those operations are ultimately protected by cryptographic keys inside your HSM. And your HSMs are actually executing the cryptographic operations in an organization. So it's the root of trust for everything you do. And like you said, you may not realize it, but everyone in modern society is utilizing HSMs in some capacity on a daily basis.
When I first encountered HSMs, it was a financial services consortium that got together to figure out how to do e-checks. And the requirement was each bank had to have an HSM to digitally sign checks and on behalf of each of their customers. And it was up to a $2 million investment for a bank to participate, because not only did they have to have a standalone appliance, they had multiple key cards, two people at the same time to do anything with it. It had to be in a literal vault as well, because now so much depended on it. It was like you put all the crown jewels in one place. Now you've got to really, really protect it, which I've always led to me, that led to this really good analogy for security in general, right? Because we're all protecting the crown jewels. Well, how do you do that? Well, you encrypt them. And essentially you can finally understand what the real crown jewels are. The attackers have to go after that hardware security module. And obviously you've built all the technology to make that, like not impossible, I guess, because nothing is, but it's come a long way.
HSMs have evolved quite a bit over the years. At Futurex, we have really focused on making HSMs much easier to use while still maintaining the security that people know and love and expect from HSMs. But everything from the initial birth of the HSM and configuration, management can now be done remotely in a secure manner. So I think if you looked at modern infrastructure, you would see a lot has changed with HSMs and how they're used. And honestly, customer use cases have expanded quite a bit with the coming of moving infrastructure to other people's infrastructure with cloud environments and SaaS models. HSMs have had to evolve to support those use cases. And you mentioned the payment use case earlier, and that is true there as well. Many organizations are moving their payment applications to the cloud. They're moving their enterprise security applications to the cloud. And so HSMs have had to evolve to keep up with those trends and support those use cases.
I think the most important evolution was that HSM as a service concept. And I've seen multiple ways to do it, still standalone hardware you have some control over, though the security of that hardware is, offloaded to the infrastructure provider. But also, I guess cheap and dirty HSMs that use the secure enclave and Intel chips. Walk us through that and introduce us to FuturexX's CryptoHub cloud.
Yeah, so Futurex offers what we call CryptoHub Cloud, and it's meant to be not just our cloud HSM, our HSM used in cloud environments, but also your centralized cryptographic service provider. So HSMs are great devices. They're used for storing keys, for executing cryptographic operations. But as a standalone device, they're not going to do much without interfacing with other applications that are used in security infrastructure. And that's where CryptoHub Cloud has really become a spotlight in an organization's environment. So it's really meant to be the centralized cryptographic service provider for an organization, whether you need to store keys that are utilized in your enterprise, in the cloud, whether they're used for issuing certificates or protecting data, or just the general use case of HSMs, whether in that payment use case you mentioned earlier, or in what we call general purpose use cases, everything from encrypting databases to managing website keys. So our solution is very unique in that aspect, but it gives you everything that a traditional HSM would have. So it's FIPS 140 validated. It's a dedicated cryptographic processing unit, which is role-based but cloud native. And unlike some solutions that operate inside, let's say, AWS or Azure shared infrastructure, our cloud HSMs run in purpose-built cryptographic environments that we manage, and they're fully isolated from some of the risks that you get from multi-tenant environments. And that gives our customers full control and predictable performance and independence from the cloud provider's native crypto stack. And that's been a big selling point and a big reason why organizations have really embraced our CryptoHub solution, in that they store data in these cloud providers, but they don't want the keys that are protecting this data to be in the same place that their data is being stored. So having segmentation there has been very important for organizations, and honestly enforced by a lot of different regulatory bodies. So with that, you're not beholden to their roadmap and their visibility model or their compliance framework. You get all the agility of the cloud, like elastic scaling and API-based key management and easy integration with DevOps pipeline without compromising your crypto governance. And that's huge for our regulated industries that we're in, that want cloud benefits but can't make security trade-offs.
Got it. Love it. But when it comes to that sensitive data, like payment information, why is relying on something like an HSM considered a best practice? Why was it better?
Not including regulatory requirements there. It's because your payment data is high value. It's a high target, and it's highly regulated. So we're talking about cardholder data, PINs, transaction authorization keys, the kind of information that, if compromised, lead to fraud and reputational loss and regulatory fees. So HSMs are considered the gold standard because they enforce security at the root. And in the payment space, for example, the PCI requirements literally mandate the use of HSMs for key generation, for distribution, and for managing different data structures like PIN blocks and cardholder data. And these devices are designed not just to perform crypto, but to do so in a way that's provable. So they generate audit logs and enforce unique controls, like you mentioned earlier, two-person control, and apply split knowledge on all of these keys that are used to protect this very high-value, high-risk data. So these are all practices that ensure the integrity of the cryptographic environment. And without HSMs, you're just trusting software. And trust in this context needs to be enforced through hardware and validated through standards, like I mentioned earlier, FIPS and PCI, who goes and look at the bits and bytes of our firmware and our processes to make sure HSMs are truly HSMs and not just protecting keys equivalent to how software would protect keys.
Makes sense. So, okay, now we're going to do a lightning round of true-false questions. Oh. And I can tell you, our audience, that you can probably answer these yourself if you're listening, because we've already heard most of these answers. But let's do this. All right, true-false. Hardware security modules are simply specialized software that runs on a standard server.
Oh, that's false, 100%. So while there are software cryptographic libraries out there, and they're commonly used, an HSM is a physical hardware appliance. So it has physical intrusion detection, secure boot, dedicated cryptographic processors. So it's actively, with and without power, monitoring for physical attacks on the server, logical attacks, and will respond to those attacks by clearing the keys. Think of it as a self-destruct mechanism if needed. So all of which are essential for meeting compliance and high assurance use cases, and take away a lot of the risks that you would get with storing keys in software, where if someone can get access to the memory on a general server and get access to those keys, your whole data governance model is broken.
Got it. True, false. Achieving FIPS 140-2 Level 3 certification indicates that an HSM is capable of detecting and responding to physical tampering attempts.
That is true. So FIPS does have different security levels, level 1, 2, 3, and 4. Level 1 and 2 can be achieved in software and really just validate that the algorithms, the cryptographic algorithms that are being executed are kosher, are being executed correctly, where level 3 brings into account the tampering events and making sure the device can detect tampering events. So things like voltage glitches, physical probing, enclosure breaches. So if you try to breach the server, and it responds again by zeroizing the keys and generating tamper alerts, where in FuturexX's case are burned into that HSM. That history of what has happened on that HSM is burned into hardware.
Cool. True, false. Implementing post-quantum cryptography support invariably necessitates replacing your existing HSM hardware.
I mentioned it at the beginning. Post-quantum cryptography is a huge shift, not just in the HSM world, but in the overall cryptographic community. And for those of your listeners that don't know, the algorithms that we use every day for everything from protecting the websites we go to and the online banking we do to protecting the data that you enter in every website that you go to or anywhere. The coming of quantum computers is going to shift the algorithms that need to be utilized there, mainly because quantum computers have been shown that they can break modern cryptography. So things like RSA and elliptic curve, which we utilize today. And so with these new algorithms, many organizations are starting to look at, how do I start implementing these new algorithms in my environment? Do I need to replace all of the HSMs and cryptographic infrastructure that I have? Do I need to update all of these thousands and hundreds of thousands of applications that I've deployed? And the answer to that is false, specifically if you've planned for something called crypto agility. And crypto agility means that you have segmented and typically centralized where your cryptographic operations are performed. So rather than relying on your application developers to know what cryptographic algorithms to use, what key sizes to use, with understanding the workflow of implementing crypto, instead, these applications can rely either on a service or some type of centralized policy to actually execute those cryptographic operations. And organizations that have deployed crypto agility find it very easy to move from one cryptographic algorithm to another because they simply hit a switch. And now this application that was using RSA can now use something like MLDSA or MLChem, which are post-quantum algorithms. And so at Futurex, we built our HSMs to be firmware upgradable, so we can introduce new algorithms like Kyber and dilithium through updates, but also be crypto agile to allow our users, our partners, our customers to define what algorithms they use and how they're deployed in their environment.
So false. Got it. True, false. Delegating encryption operations to an HSM can enhance the performance of application servers by offloading these computationally intensive tasks.
Absolutely true, especially in high throughput environments. So think TLS termination, payment authorization, signing workflows. HSMs are optimized for parallel cryptographic operations, and they have high-speed cryptographic chips that allow them to perform cryptographic operations much faster than general servers can execute them.
And enough to make up for, I don't know, whatever added latency there is because you're going to a different machine?
Absolutely. And And latency is a very important aspect to look at in your cryptographic environment. It's oftentimes dependent on your use case. And HSMs in particular have been designed to offer sub-millisecond response times. So with that, along with the parallel processing that you get, you'll find much faster throughput with cryptographic operations utilizing HSMs. And some cryptographic operations are very expensive in terms of their CPU utilization. And so offloading those to a specialized device, there's a lot of benefits to doing that.
Got it. Last one, true or false? Once a cryptographic key is securely stored within an HSM, it's impossible for it to ever be extracted in its original unencrypted form.
That's true, and that's by design. So the entire purpose of an HSM is to use the key without ever exposing it. HSMs, by definition, do not want to expose keys. So you can encrypt and decrypt and sign as long as you're authorized to do so on those HSMs. But the raw keys, they never leave the secure boundary.
Got it. That I'm sure many of my listeners will took pause at that word impossible. And as we security people are just brought up to challenge anybody who makes a claim like that. But I can assure you, I've been in the room with cryptographers and they bounce this question back and forth and they will come up with scenarios you'll never think of and make sure that they're taken care of. So great. One last question. What's a compelling story or use case demonstrating the impact of HSMs, and what's the single most important takeaway about them for our audience?
Oh, that's a good question. I'll give you two. One forward-looking and one grounded in daily operations. So the forward-looking use case involves a global financial institution that we've worked with. They had decades of customer data encrypted with RSA, which is a commonly used algorithm, standard at the time, but suddenly at risk in the face of quantum computing, which I mentioned earlier. So we helped them migrate to a hybrid encryption model using Kyber along with RSA and elliptic curve, and that's all handled inside their HSM. So that gave them quantum resistance without needing to rip and replace their entire environment. So keys were centrally managed and quantum safe and auditable. So really a textbook case for crypto agility in action. And the second example I would say is more everyday. We work with a lot of different manufacturers of all types of devices, everything from chips to rockets. And in this case, a global satellite provider. They needed to support thousands of endpoints, each requiring secure, regular key rotation. And so rather than managing the complexity of that in software, we deployed our centralized HSM infrastructure that handled the key generation, rotation, and injection of those keys. We call it over-the-air keying, all tied to audit policies and controls. So they reduced their operational overhead because all of that was offloaded to the HSMs. Obviously, they tightened security and passed the regulatory audits that they had to go through, I would say, with flying colors. So the bigger message, though, is HSMs don't just solve crypto problems. They create predictability and enforce policy and allow you to have a true security model that is effective at scale.
Wonderful. Thank you so much, David, for joining us today. That was a great conversation about HSMs. And also, thank you to everyone listening. We hope you took a lot away from today's podcast. For further information on what we've talked about, please head over to FutureX.com. We'll be back next week with another episode in our podcast series. Until then, make sure you subscribe to this podcast on all major platforms and follow the conversation on our socials at EM360Tech on Twitter and LinkedIn. And for more great daily content, head on over to EM360Tech.com.